Entonces, we're going to do the interval from -1 to 2, find the average value, okay? And then what we're going to do is just try to prove by looking at the graph and the drawing that in fact one part fills out this gap. Okay, that's the idea. So according to this, the average value is going to be 1 over, this would be A and this would be B. Okay? 1 over 2 minus 1. So we have 3 units, that's the base. Okay? That's the base of that shape. But the average value is going to give us an average height of all of the heights that we have from here all the way up to here. Okay? We're going to get that average height. The integral from A, which is -1, to B, which is 2, of this function and dx. Okay? So now, of course, in this case, this is a very simple integral. And this is going to become 1/3. Okay? And then we have the integral of this is going to be, let's write it like this, x cubed over 3 plus x. And we're going to evaluate that from -1 to 2. Okay? So the only extra thing that we have right now is that factor, which is in fact a fraction, a division. Okay? This 1/3 compared to what we already knew how to do, which is this definite integral. Okay? So now we're going to evaluate. I'm going to leave this 1/3 multiplying everything. Okay? So then we're going to evaluate with 2. So we got 2 cubed over 3 plus 2. And then we have -1 cubed over 3 plus -1. Okay? So we evaluate on the upper limit and then subtract the lower limit. And this is going to be 1/3 of, then we have, this is 8/3. Okay? And I'm going to write everything in thirds so we can add easier. This is 6/3. Okay? Then, this is -1. So it's going to be negative times negative. This is going to be positive 1/3. Okay? And this one is also going to be positive, right? Because we got minus times minus, and this is going to be plus, and I'm going to write it as 3/3. Okay? So then we add all those thirds together, and what we get is what? 14, 15, 18 thirds, right?
Yeah.
So 18 thirds, this whole thing is 6. We have 1/3 times 6, so that is 2. Okay, this is the average value, 2. Okay, so what that means is that if we draw a line where we have that average value, okay, which is this thing that we got over here, then this part, okay, we're going to calculate that area, is going to fill this. Okay, in other words, what is the area beneath the curve as we did before? It's 6 units, okay? It's like the part to the right of the integral, not considering this. This is the area, okay? So the area is 6. Okay, 6 square units. Now, if we calculate the area that we have from, and let me try to do this drawing like this. If we calculate the area of that function from 1 to 2 using the integral, okay, we would have all of this, right? And then we can subtract this rectangle, which has an area of how many units? This area is 2 square units, because it has a base of 1, and this is a rectangle. It's very clear to see. A rectangle with a base of 1 and a height of 2. Okay? Now, so that will allow us to find the exact area of this. It looks like a triangle, but it's not a triangle. And then we can find out this area. How would we find it? This one here. I'm asking. How can we find this exact area? Okay, we do from -1 to 1, and that will give us the area below. But if we subtract that from this square, because that's a square, this the area of this square, I'm going to write like area of the square, is 4 square units, right? No? So I'm considering this whole square. It's a perfect square. Now we have 2, a base of 2 and a height of 2. Okay, so if we subtract from that the area, I'm going to put it like with little dots here, that we're going to get from the integral, okay, square minus leopard shaped area, we're going to get this one here. And it should be exactly what we get from here. Okay, so let's call this one area 1. Now, on the practical side, the problem of finding the average value ended here. That was it. Okay? This is just out of mathematical curiosity. Okay? And to see that in fact, that part that is above the rectangle is going to fill out this space here. And we'll have a perfect rectangle that will have the same area. Okay? One is an irregular shape because it has this very crazy top. And one is a very regular shape, which is the rectangle. Okay? This value. Okay? Yeah, the line. It's the average value, it's like the average height of the function. Okay? This too is not an area. This is a value of y, a value of the function. Okay? That will be the average height of a rectangle that has the same area as all of this and the same base. Okay? So, okay, we're going to call that area 1 and we're going to find out what area 2 is, and they should be the same. Right?